So we're going to kick off with looking at our last part from last week, and I'm going to remodel that quickly, but it'll help anyone that's sort of missed out on anything crucial there. So, this is the finished part and what we were aiming for. One small detail left off this is just a small fillet to go on these outside edges. 0.5 of a millimetre, but that's not crucial to the overall model. So I'm going to model this from scratch, including the sketch, very quickly. All right? If you see something on screen you're not sure how to do, yell out and I'll just repeat it. All right? So start on the front plane, and I'll start with 2 lines and make them for construction. When I'm starting this bottom edge, I'm making sure that it's above that construction line because I want to leave a hole in the middle of my part when I revolve it. I double click here, that ends that line, and then I can start a new line. And here I'm doing 2 circles, and then pressing trim to trim those away to create my overall shape. Then mirror, and dimension. Is that straight enough, easy enough for everyone? Yeah? Good. So all the dimensions I'm using should be in the drawings. There's nothing here that's, random. Okay. Then we hit revolve. When we revolve and there's multiple construction lines in a sketch, you have to select one. All right. Compared to when we did the washer earlier, which only had 1 construction line, this one's got 2. Now I'm just going to do this without moving things around in the feature tree, so this is the correct order. So I'm going to fillet these faces. I'm going to create a rib, which requires just a vertical line. If I want to fully define that, I need to add some dimensions in. Remember, I want all of your sketches fully defined. So even a sketch like this should be a black line with some dimensions. Hit the rib feature, 3 millimeters thick, 2-degree draft angle. Then when I fillet the rib, I'm just selecting this top face. When I select the face, it goes around all the edges of that face, and because of the curves on the shape here, that fillet, which is tangent propagation, propagates all the way around that. circular pattern. Pick the axis in the middle. Features is the rib and the fillet. Equal spacing to 7. Right plane for mirror. Again, rib, fillet, pattern. I also need to check this box here, geometry pattern, to enable this to work. That's it.
Can you go back to your like the actual sketch of the rib? 9. Okay, cheers.
Any other questions on this one? Based on the responses, I should assume everyone's going to get this 100% right.
There was a radius you put on the outside of
That's
the wheel,
right, yeah.
fillet.
This one here, just on that outside edge, 0.5 of a mil.
0.5, okay.
So with the mirror, you select the circular pattern.
Yeah. So I've seen this come up with a few people, so I'll just talk about that quickly. When you're doing the circular pattern,
What does the geometry pattern tick box affect? Why does that make it magically work?
to be honest, I can't explain it. Just do it.
Complicated?
Yeah, this is very complicated. Google it if you really want to know. I just want to explain something quickly with the patterns, okay? And it's the same with the mirror. So when I'm doing that circular pattern, you can see here, when I click on that rib, it gives me a preview, and that looks pretty close to what we're doing, right? If I just tick that one, it's only including the rib feature, it's not including the fillet around the edges as well. You have to manually include that fillet feature here in the features and faces to pattern. So you've got to make sure you select that fillet as well. It's a similar thing when you do the mirror. So when you do the mirror, all right, if I just select one of those patterned bodies or patterned faces, you can see the preview there, it's showing me the entire pattern, okay? Now in this case, it's actually worked compared to bits earlier. Typically though, what you should be doing when you're doing that mirror is including the original feature as well. So you'd want to normally include that rib and that fillet as well as the circular pattern. Okay? If you're encountering errors, make sure you've got those 3 selected.
If we were to edit the original fillet and rib having not mirrored them, would that affect the drawing later on?
Having not mirrored.
Because you know how you mirrored just the circular pattern and it took everything with it.
Yeah.
Is that why we needed to mirror the rib and the fillet as well?
Let's test. Okay, so if we edit, basically what you can see is a mirror, okay, which signifies that when I edit this fillet size, so let's go down to 0.5, that's going to be reflected on the other side. Because it's derived from that. So even though it's not included in that mirror feature, because what you can see there is, you can assume, safe to assume that it will be. Any other questions on this one?
0.45.
Very good.
Point
0.5 for what? The one on the outside?
That outside one.
0.5.
0.5.
Okay, so what we're going to do now, once you've done that part, I'd like you just to open all of your parts. Just have them open in SolidWorks. So, a few tricks just to move between files and to see, or basically sorting through your interface, okay, and shortcuts. We'll touch on some things now. When you're working with assemblies, it can be useful to have things open because it just makes it quick to insert. Right, when you start a new assembly and you go insert part, anything that's open will already be there, okay, to bring in. So when you have multiple parts open, if you hit Control-Tab on your keyboard and hold down Control, you'll bring up this Open Documents window and you'll be able to cycle through. Alright, when you let go of Control, it'll open up that file. So that can be useful for trying to move between files if you're making changes or anything like that. You can also, once you've hit Control-Tab and you're still holding the Control key down, you can just move with your mouse and click on one of those files. Okay. So before we get into the assembly, I'm just going to look at a couple of changes that we can make to these based on those documents that we've received, that updated dimensions we got from last week. So who can point out for me something on this document that's different from the week 1 stuff?
The washer has
Sorry, part 3?
Yeah, part 3 is a lot shorter.
Shorter, okay. The 76 is different.
Also, the holes the sensor hole is at the bottom rather than at the top.
Yep,
That makes sense.
yep, that does. And there's only 5 holes.
Yep.
Okay, and we've got a thickness there. All right, so we're going to make those changes. Okay, so we go to that part, and if you've set up correctly with all your dimensions, there should be some things that we can do pretty quickly. So here, that A to B, I can press in there, 76, easy, and the thickness, I can change that to 2. Now the holes, it's a little bit different. I can change this number to 5, all right, but see how it's still at the top? I need to bring that around to the bottom. All right, so for that change, I need to edit the sketch. So if you want to edit a sketch that's in a feature, you can actually click on the feature in the feature tree and see this icon that comes up here, edit sketch. You can click that, and then you're editing that sketch. Willie, yeah? Willie? What do I need to do to get that circle to the bottom?
I don't remember how I did it last week. I think I got rid of the constraint that made it vertical and then dragged it around to the bottom basically.
Yeah, he's spot on. All right. So what's holding that circle up the top there is its dimension here, 15, and also that vertical relation. Now, it should still retain a vertical relation. There's 2 ways of doing this. The first one is deleting that, moving this around to the bottom, and then adding it back. Okay. The other way is to delete that dimension, 15, and then you can actually drag it through and out. Either way, same result. Either way, same number of clicks. That's fine. So you want to move those holes around to get that hole at the bottom. Okay. All right, it's good. Save. Could someone else point out something for me?
So-
Chris, while we're on that
Yeah.
side plate, just the radius of the bottom large circle seems a lot larger.
Yeah, you are correct.
But I can't find anywhere else on the document of dimension for that.
No, it's a good point. Okay, let's make it bigger. Let's go 80. Okay.
the wheel 76.
Yeah, you're pretty smart, aren't you? It's good. It's good. Okay. Was Zach saying? Okay, he's made that diameter at the bottom 80. Now, right now that looks wrong here, but I need to update the rest of the proportions. Okay, so I know the 76 is right here. Get the 80 at the bottom right. So perhaps the top might need to be a bit bigger. Perhaps the hole spacing needs to be bigger. Perhaps the holes themselves need to be bigger. All right, so there's a few different things you can do that might affect how it looks. The other thing that I think Zach's probably done is had a look here at this. And you can start to see the proportions of one part relative to another. If you know the diameter of the wheel is 76, and that's smaller than the diameter of this part on the outside, then it obviously needs to be bigger than that, doesn't it? Yeah. So it's really good. Okay, what's next? Someone else? Something that's different.
There's a chamfer or a
This
fillet
one?
on the on the
Which one?
This is on the washer. There's a round fillet, and
Yep.
then on the bush there's also, it looks like there's a
Yep. On the bush, yeah, there's a fillet. We'll do that one, that's pretty easy. The one on the washer, you're right as well, there is a fillet on that. We'll come back to that one. So the one on this part we'll come back to, leave that for now. But on the bush here, we can add a fillet. So 1 millimeter outside surface, okay. The other thing on this, it's got a width of 25. So we can update that if you had 30 like me. Save that. All right, anything else? All right, the main one that someone should have picked up is that this one's got text cut into it. All right, not quite off center, on center, but we're going to do that detail now. It's also got this dimension here, 12.5 for that radius and 2.5 for the thickness. So we'll put those in as well. So that 90, that's changed to 76. Diameter, what did I say? 25, yep. The thickness, 2.5. Okay, so on this one, what we have is some text engraved. All right, CLB my initials. When you do yours, you can do your own initials, you can do your own brand name, whatever you want. Just don't do CLB manufacturing. Let's see who's listening to my instructions. So to do that text, it's just a sketch, all right? And there's actually a text tool. So we start a sketch on this face. And the text tool you can see up here says text. I'll show you how that works. So I'll click that text tool, and what happens is, in the text here I can type in, and you can see in my viewport that that text has gone to the origin. All right? So by default it will go there. What it's really good at though is going around curves or edges or lines. So if I wanted to do text around a curve, I can select the curve here, and you can see that text will actually follow that curve. Now you can edit the direction of the text by pressing these buttons. So I can flip the side the text is on, I can flip the direction the text is going, I can make the text justified or centered. All right, so if you're trying to make a clock, for instance, you could just have a circle there and your numbers and just justify them around a certain arc. Okay, so there are easy ways to set those sort of things up. What's important to note though, when I have something like this, okay, when I'm using this text, the normal rules apply when you're trying to do your extrude or cut. You don't want lines crossing over each other, right? The one thing with text is you actually can't trim them. So even though it's blue lines there, you can't actually trim away like you could in Illustrator, those little sections. So if you are using text, you need to make sure that there's no overlaps, all right, to use them properly when you want to do a split line or a cut or an extrude. Now we want to have this in the middle of our part, and What it doesn't say here, but what I'll tell you is the text is 3 millimeters high. Okay, so we want it centered in our part and 3 millimeters high. So I'm just going to press the tick on that one, leave it for a second. To come back and edit it, I'll double click it later, but just press the tick and it'll stay there. I'm going to add a construction line up the middle. And then I'm just going to add another construction line, which goes from here to here, next to it. And what I can do here is put a dimension between those that's 1.5 millimeters, which will give me a baseline to put my text on. Alternatively, you can do this without the line at the middle and just dimension it from the origin. So once I've got a curve there, I can double click my text, and where I've got the edge selected here, I can delete that and select this new line. Just going to center my text, flip it the direction so it's around the right way. And then to change the font or the height of the text, I want to uncheck this box which says use document font. Press the font button. And then here, you can choose any font that's on the system. The only thing you need to do is make sure that it's 3 millimeters in height. So you can use any font you want, so long as there's no overlapping of letters. When you're happy, press OK. And then go features extruded cut. If it works, you should get the yellow preview. And when you cut, just make the cut 0.2 of a millimeter. Okay, like an engraving, press OK. And there is your detail. Now what you can see there, mine hasn't included that L. So I'm going to have to change the font. Go and edit the sketch. There's no particular reason why that one hasn't worked, but change it anyway. Alright, there we go. And save. We'll keep going now with some assembly stuff. So one of those other tools, once you have your parts open, is you can click on window and tile, and you can either tile horizontally or vertically, but that will show you all of your parts as well. All right, it's not a very useful way of actually working, but you can then visualize what you've got open at the time. If you want to increase the size of those, and let's say there are only 4 parts you're working on, you can minimize some, and once they're minimized and you press tile, okay, it will just tile the remaining ones. Okay. Once you go full screen again, the rest will all go back to full screen. All right, but the others they'll remain minimized until you go through and cycle, get them all back to maximize. There's also this button here at the top right of the viewport. Click to tile to the right or the left, where you can basically put one file, one part just to the right, and it'll show the other 2. Okay, so there's a few different ways you can play around. So we're going to start with our assembly now. Have a look at our drawing here. We're going to start with this sub-assembly. So we're going to build the sub-assembly first, which has those parts, 1, 2 and 4. And then we're going to create a new assembly and put that sub-assembly into the new one. But I want to make sure we all get the basics right first, with just the simple assembly to start. When we're starting our assemblies, you always want to consider what's going to be the easiest way to get everything in there and aligned properly. So you typically want to start with something that's central to your assembly. If you're assembling a car, again, I was just using that as an example, you wouldn't start assembling the whole car with a tyre and working out from there. You start with a central part, which might be the main chassis. Okay, so let's start with something central. In this case, we'll use this form bracket as our first part because it's symmetrical, okay, right down the middle. It's got holes here on the sides. It's got a hole on the top for the pivot pin and a washer, right, to align it to, and some flat faces here for later on mating to these side plates once it's in the general assembly. So that'll be our first part. So what we're going to do, to start your assemblies, there's two ways. You can go File, Make Assembly from Part, or you can go File, New, and Assembly. Press OK. And as I said earlier, when you have your parts open in SolidWorks, you can see them here as parts ready for you to insert into that assembly. If you have nothing open, all you have to do is press Browse, okay, and you can browse for your files, or you can click and drag straight from Windows Explorer into SolidWorks Assembly to add parts. We're going to do it the normal way here, and I'll just explain a couple of things with starting the assembly and how things can be different. So the first one I'm going to do, I selected part 4, and I'm going to press the tick as the first one. I'm going to do 2 more. I'm going to do number 4 again, but this time I'm going to just drop it on the screen. And I'll just stick with those 2 for now. Alright, so the very first part you put into an assembly will have this F icon next to it. Okay, in the feature tree you'll have an F in brackets. That means it's fixed in place. So it's pretty much locked into position. Any other part after that that you bring in will be floating. So this one is the first one, it's fixed. If I try and move it, I get a note that says the selected component is fixed, it cannot be moved. This one, the second one, this is floating. I can move this anywhere. That has that minus sign next to it in the feature tree. And that minus sign signifies that it's underdefined. So, you can float a fixed part by right-clicking and then selecting float. And then I can move that first one around. You can fix a part by right-clicking and going fix. Now, our aim is not to fix or float anything, but to fully define everything using mates. Now, when you bring a part in, so I'm just going to insert a third part now. When I select that part 4 and I hover over the tick here and I press the tick, that part's now fixed again. But what's actually happened is that part has been inserted to match the planes of the part with the planes of the assembly. So this part, which has a front, top and right plane, is now matching the front, top and right plane of the assembly. And that sort of thing is key for how we set up our first parts. Now, when you're in assembly, you can delete parts by selecting them and pressing delete on the keyboard and enter. So the correct way to set up your assembly, bring in your first part, make sure it's floating so you can move it around. And to get used to mates and to set things up properly, what we do with this first part is mate the planes of this part to the planes of the assembly. So when you mate, there's a couple of ways of doing it. You've got the mate icon here, which is the paperclip on the top left. my preferred method for mating planes is to select them in the feature tree by holding Control and then hitting the mate icon. And that will bring them together. Once they've added that mate here, and it's a coincident mate, so those two are touching, I can press the tick. That mate is added down here. If I want to edit it, I can click it and change things. But if I want to keep going, I can now just select my next planes, which is going to be top and top. And I can press the tick on this shortcut menu. And then right and right, tick. Those three mates there ready to go. To add, press the tick here to go OK. And now you'll see there's no F, there's no minus sign. This part is fully defined. All right, so if I try and drag that, I can't. At the bottom of my page of the screen, it says fully defined as well, telling me my assembly is fully defined. All right, so that's the correct way you get your first part in. I'll show you the next two parts, and then I'll give you a chance to have a look at it yourselves. So insert component, I'm going to bring in part 1 and part 2. So the other way to do mates, once you've got your parts in there floating, is just to hit the mate icon and then just click on the parts that you think you need to join together. So here I'm going to line up the outside face of this washer and the outside of this pivot pin circular area. Now, even though it's the outside of this part and the inside face of this, it doesn't matter that I'm selecting outside and outside because they're both circular. Okay, so they both share the same axis. So I could even select the outside face here because that's circular as well. It doesn't need to be the inside and outside of something when you mate it together. So that type of mate there's a concentric mate. Press OK. You can also press lock rotation sometimes. Okay, if you don't want something to twist around, you can press that to stop it twisting. For this project, just leave that unlocked. Press the tick. Then I'm going to do the top surface of the form bracket and the underside surface of the pivot pin. Inside circle, outside, underneath, top, and then press the tick. Alright, so let's move those into position. They're still underdefined. I can tell because now I can drag them, so I can actually rotate them. It's the same with the washer, although it's a bit harder to see, but that's rotating as well. We want everything to be fully defined. One of the reasons for that is in our next project, we're going to do some section views, all right, some drawings to explain everything. If you have this twisted, okay, not perfectly straight, when you do a section view, so you're going to get like a bit of an off shape up here. It's not going to be symmetrical. And that can cause confusion for the manufacturers or issues when you're communicating that detail to your suppliers. Right. So that's one of the reasons why we're going to try and get this stuff fully defined and lined up properly, so it's nice and straight. So with this part, there's no faces, flat faces that I can get it to mate to, but what I can do is maximize that part here, have a look at the planes, and I can see the front plane there. I can select that front plane, hit mate, and then I can select this front face of the form bracket, and that'll add a parallel mate. So it's going to line them up, make sure they're straight. Press the tick. And now you can see that part's fully defined, so it's not going to twist anymore. So I'll do the same thing for the washer, front plane and front plane, or front plane and front face. Tick, okay, and now that's fully defined assembly. Alright, last thing, save that. Rebuilding, that's fine. So it's when you save assembly files, different to part files. Okay, they've got a different file extension. Save it in the same folder with all the other parts. And you want to save this subassembly 01, okay, like you've got it here, SA01, and then in the description, subassembly. Save. And that's that. That's done. All right, I'm just going to show you how to start the general assembly, and then I'll leave it. So now we've got that one. We want to make an assembly from this. We're going to bring that in as our first part of the main assembly. I'm going to float that. I'm going to do the same thing with the planes. Front, top, and right planes mated together to get it fully defined. Okay, and then it's in this one that I would add in my other parts. So my part 3, part 5, bring in part 6, and part 7, the wheel. Right, so just in your assemblies, so you can insert multiple parts the same way you've just done there, or you can create copies. So if I want to copy this part because I want to make 2, I can hold Control, click and drag, and that makes a copy. The other thing you can do is select a part, press Control C and Control V, creates a copy. The copy's in exactly the same spot though. So if the part's mated, fully mated, it can be hard to move it out of position because there's another part on top of it. But that's all of the parts there. So we'll leave it there for now, let you play around with those, get the sub-assembly right first, and then create your general assembly from that. Next we'll come back to look at how to make these together and then add in the nuts and bolts. All right, that'll be the next thing we'll talk about. Okay. Right, so it looks like everyone's making a pretty good start on those assemblies. So we're going to keep that going now and show you a few more tricks with doing those, and a few different ways of using the assembly and looking at it and its parts. So I'm going to very quickly add the remaining mates for this one. And as we go, I'll show you a few of the different sorts of mates that we can use. So what I like to do when I mate is do all the basic ones first. So all the concentric mates and coincident mates are the easy ones to get done early. Now, when you mating parts, if you click and hold your mouse, you can select and move a part without selecting it to actually mate something. And that can make it easy to add some mates like those concentric ones there to get parts in the right position. Now this is a bit of a tricky one here. All right, the text of this part's on the opposite side. The way to do it, when you do your concentric mate, see these arrows here, flip mate alignment, press that button, and that'll flip it to the other side. Okay. So that's all the basic ones. Ones I've got left are a little bit of swinging parts and the position of the wheel and the bushes. So first, the swinging parts. You just have to find a flat face to match them up. So firstly, those two center parts are going to match there. Then I can match this face, which is going to be vertical, with this face. and they'll be parallel. Right, and that's going to stop the swinging for all of those. So you can see now 3, 5 are both fully defined. For the bush, now I could mate that to one side, all right, if the gap was correct and the size was correct. Another way of doing it, and this is why we often, when we extrude things, we extrude mid-plane, is I can use the right plane that's in the middle of that part, hold control, select the right plane of the assembly to get it mated in the middle. All right? That way, no matter what size it is, it's always going to be central. I'll do the same with the one at the bottom. And you do the same thing with the wheel. Right plane. Get in the right position. So then those parts which are underdefined, it's just about rotating. So you can see the front plane there. If I show that, show plane, you can see when I move this around that front plane's moving. Or I can mate that front plane and this face here to stop it rotating. Front, that one. And same for the wheel. Alright, and now my assembly is fully defined. Alright, so that's all the mate's done. Save. If you haven't saved yet, it's probably a good idea. Get it done. Okay, so now we've got that done, we can see some things straight away that are wrong with our assembly. Firstly, this part here, the form bracket and the bush, they're interfering. We know from our dimensions here that bush size is 13. Now in the section view we can see that the bush sits inside the form bracket. Right, so that means the whole of the form bracket needs to be larger than the bush. So one of the good things with the assembly is the ability to edit your parts when you're in the assembly. I don't need to go out to that part to make the change. I can do it inside here. To do that, I'm going to select that part and I'm going to select this button here, Edit Part, and that takes me from assembly mode into part mode. Now I'm in part mode. It's just like you're in that part file. I can click on this and I can click on the hole size and I can see the hole, and I can change my measurement and see how it edits within the assembly, and you can see now I've got that clearance. When I'm done, hit Edit Component again to get out, and you're back in assembly mode. Alright, so that was one of the interfering parts. There's a couple more that aren't quite right. One of the things that you'll need to do before we submit, and we're going to be submitting during next week's class, probably halfway through class, is to do a bit of spot the difference. The way to do that is to go to an isometric view. So we've got all the front, top, side views here, but you've got here isometric, diametric and trimetric. If you go to the isometric view and just zoom out with your mouse, zoom out and in till you get on the side here, you can bring up this PDF and this drawing view, put that on the side of your screen, get that view up, and just try and pick out the differences between what you've modelled and what that image is showing here. We don't have the nuts and bolts yet, we'll put that in soon, but there's a few things you could probably point out straight away that are incorrect dimensions somewhere. So long as all your other dimensions are correct with your parts, as far as you've matched up with everything in this file, what's left is for you to determine based on what you can see here. So we're starting to build on that attention to detail aspect. All right, I'm not going to tell you all the answers. This is where you need to have a look for yourself and try and work out what size some things need to be. We'll touch on that a bit more again next week. Right. So just some other useful tools in the assembly. You can hide and make parts transparent. So to make a part transparent, you can click on it here or click on it in the view in the feature tree. You can see the icon here, change transparency, and that'll make that part transparent. Or you can hide parts totally. To do that, click on the part again and click hide and hide. All right, and that will hide them. You can see that they're hidden in the feature tree. Okay, they've got outlines next to them. To turn them back, you just click those icons again for transparency, or here to show. Now when something's transparent, you can't click on it in the viewport unless it's the only thing that you can see between you and the background. So I can select it here because there's nothing behind it, but when I'm here, can't select it. Unless you hold down the Shift key. Shift lets you select things that are transparent or clear. All right, no matter what's behind them. So, now we're going to add the nuts and bolts. SolidWorks has built into it something called the toolbox. Now that can be found in the design library. So on the side of the page here, screen, design library icon, you can click that. You can see the toolbox. And the toolbox is like a plugin. You've got to turn it on for it to activate. So you just, it's called an add-in. SolidWorks plugins are called add-ins. So you click add-in now and that'll turn it on. Now what the toolbox is a collection of parts that you can use in your assemblies, and they're typically common parts like nuts and bolts. Depending on the types of standards that you want to use, there's going to be different options there. So ANSI inch and metric, you've got Australian standards, British, you've got international, there's some structural stuff like steel beams. There's a lot of different things there. Have a look through them and just acquaint yourself with what's there. We're just looking for, in our case, I think it's shown over here somewhere, an M10 bolt and an M10 nut. And the length of the bolt should be 45 millimeters. So, just before I try and demonstrate this, I want to explain that the toolbox is really meant for single user environments, and that's what this note here says. A single user environment is when you're on your desktop at work or at home or your laptop and it's just that computer. It's not linked to a server where you're pulling files from different locations. The difficulty here is when you create a toolbox part, it wants to create that file on the hard drive. We don't have access to the hard drive here, so often that can fail. Right? So there are different ways of getting around this, but it can also throw up problems. So just be aware of that when we're playing with the toolbox. Not everything will work perfectly. So we'll have a look at ANSI metric and bolts and any type of bolt. Going to go for hex head, heavy hex flange. Now not every bolt here that you see will have every type of size. So we have to find one that's going to suit our assembly. The easiest way to do that is to click and drag that bolt and drag it over a hole in your assembly. Now, even though that note on screen says there's no matching size for this component, it looks like it might fit. So I'm going to let go of the mouse, and it's creating that part. Now, at the moment, it's got it as M6. What it's doing is it's sizing the bolt to match the hole. Problem is, my hole sizes are wrong. Right, so I'm going to press escape to cancel that, and I'm going to edit these parts to fix up the hole size. So because they're M10 nuts and bolts, that means my holes need to be at least 10 millimeters or bigger to allow for some clearance. So I'm going to make them 10.2. Make sure both my side plate and reinforcing plate have the same size holes. And we'll try again. Alright, now it still says there's no matching size, but I think we'll be okay. So I'll let go of the mouse. So M10 is correct. On the side of the screen here in the properties, I can now select the length, go down to 45. Thread length. So the threads can go part way or all the way. I'm just going to go, leave it at 26. And thread display. So a simplified thread display is basically none. Or you can go cosmetic, and it's just going to show like a graphic on the outside. Or you can go schematic, and it'll actually show a cut done into that bolt. This is not a proper thread though. A proper thread would be a bit more like a spiral. Alright, so it would actually thread onto something. This is just a cut, which shows a bit of a pattern along that edge. But when I'm done, press the tick, and it'll now let me add another copy of that part on another hole. And when I'm done there, press the cross. What it's done when I've brought those parts in, it's actually added mates for me automatically. So not only is it sized correctly to the hole, but it's also added a coincident and a concentric mate around that hole position. To finish that off, I just want to fully define that by grabbing one of these faces and just making it parallel to stop it rotating. Alright, so that worked pretty well. I'm going to do the same thing now with a nut. So the alternative way of doing this, if it doesn't work when you click and drag, for whatever reason, is you can right click on the part and press create part. And it's going to open up in a new file, and in that file you can do the same thing. So just standalone, you can create your part, press the tick. Now that's created it, and if I press Control Tab you can see it here. Once it's created, I can then insert that into my assembly, and with the nuts they'll do a similar thing like the bolts. They'll automatically mate, you can get your mouse in the right position, to the end of that bolt or that end surface. There we go. To finish off, just going to mate those, make sure they are fully defined. So select that face, that plane. And there we go. Any questions? Pretty handy tool. Sure saves us having to model them as well. So in your own time, have a look through. You can see all the different types of parts there are in here for different uses. Now, what we want to do with ours, these parts, and where you can encounter trouble in the toolbox when you're on a server, it's fine now, but when I save this file, close it and reopen it later, I might lose those parts. I might lose the reference or a link to them. I don't want to demo that right now. We'll probably see that happen next week in class. But what I do want you... Okay guys, really good progress. I'm going to touch on a few things now which are the sort of things that can come up when you're learning this stuff. So everything that I've done on screen and for the demo so far has sort of just been doing it perfectly, but as you're learning, you're going to make mistakes and it's going to cause some problems. All right, so I want to try and simulate some of those so you can sort of see what are some of the possibilities are. So to do that, I'm just going to start a completely new assembly and try and do some of those mistakes. So let's see what we can do. All right, so first thing is with the mates. So the mates that you add in this assembly, close that one, in this assembly here, when you press that arrow here and that drop down, you can see they're all the mates that we've added. Mates are a lot like features or sketches, you can edit them. So if you do one incorrectly or you need to change it, you can edit it or delete it, all right, if it's causing you problems. You can also hover over them and it will indicate in the viewport what all of the mates are. If they're coincident between faces or planes, okay, or concentric between two different parts, it'll highlight for you. Often I find that the problems that people have when they're doing their mates is because they've accidentally clicked on the wrong edges or faces or type of mates. And then when they do the correct one, they're unable to because of what they've already done to begin with. And what they've done to begin with might just be a very small mistake, but it's caused, or it's preventing them from doing, getting the right one done. So here's a bit of an example. So I want to make this hole and this one concentric. Now, that looked like it worked, but I'm not sure. I'll try again. Press concentric. I get this issue here, mate. The components can be moved to a position which satisfies this mate. Cylinders are not concentric. Well, I'm trying to make them concentric. Distance between cylinders is 22.2, blah, blah. I'm going to press the tick and just try and add it anyway. Okay, press OK. Otherwise I might add, I want to get this face to match this face. So the sort of errors that you get in assemblies typically look like this. So in my viewport, you can see there's one part that's red and one that's brown or yellow. And in my mates, there's a few red and yellow errors. Another one that I've seen a lot already today is this one. Right. So the lock mate. So a lock mate is basically selecting two parts and locking them in place where they are together. But there's no reference, there's no coincident or concentric or parallel, they're just locked in position. So that mate's going to cause you a bunch of errors. So if you have any of those in your mates folder, just select them and delete them. Right, so to delete a mate, just select it, press delete on your keyboard and enter, and it'll remove it. Now you might get this pop up from time to time as well. It's a summary box. It's showing you the errors and what's happening, whether it's a warning or an error, what the feature is, and the description of it. Now, typically in your assembly, it's going to be all about mates, and the description will be it's over-defining the assembly, or it can't be worked out. If you think back to the sketches, and when I was showing you how sketches can be over-defined, the example was when you have a vertical line, and you also tell that line to be horizontal. Okay, it can't be both at the same time. The same thing's happening with the mates. So we've added one mate accidentally, and then we're trying to tell those parts to do something else, and they're conflicting. Okay, it's either one or the other. So what we have to do is work out which mate is wrong and remove it or edit it to get it so it's the correct mate. this what's wrong box here, if it pops up a lot and really annoys you, you can just tick those, uncheck them and turn it off. Just close it. It's just a warning pop-up for you. So if we have a look at our mates, you can see I've got these tangent ones here. All right, they're the ones that I've added incorrectly. And then these concentric ones, coincident, they're red, marked as red, but they're actually correct mates. Right? But because I've added them second, like I've added them last, SolidWorks is saying, oh no, they're the ones that it thinks are wrong. Right? But these tangent ones are wrong. So a tangent one is done tangent between this face here, this circular face, and this flat face. So I don't want that. Delete. Okay. That's one step done. Next one, another tangent mate here. So this tangent mate, this face to this curve, is preventing these two circles from being concentric. I delete this tangent mate, and once I just click that one, it's sort of updated. Okay, and now that's got that concentric mate there. All right, so once you clear those mates that have errors, you're able to then go back and add the other correct mates that you actually need. The other thing that can happen is that changing your parts can affect your mates as well. So this part here and this one, they have a concentric mate, as you can see there. If I go and edit this part, and I edit this sketch, and I delete this circle, and replace it with another circle, which is exactly the same, 13.2. Okay, I haven't really changed anything. And we'll see if SolidWorks how it reacts to it. Yeah, I need to do a better example. Right, let's change that to a hexagon. And I still have the cut there, but obviously now that circle relation is gone. So that means these mates here, concentric ones, it's now suppressed those because the hole that concentric mate was referencing between those two parts is no longer in our part. It's no longer in our file, so it doesn't know what it's supposed to be referencing, so it's gone big red error. You know what's going on here. It can't work it out. So when you see a mate like that that's sort of suppressed or turned off, it's grayed out, it's typically because you've changed something in your files. And sometimes it can be as simple as converting a part, this one, converting it from the normal part to a sheet metal part. Right, so this is something we're going to do in project 2. I'll show you right now. So I'm going to convert this to sheet metal. I'm going to select that face, click these bends, press OK. Looks exactly the same. Alright, the difference is now, if I just turn on my sheet metal tab, this part can flatten like a metal part. Right, nothing's changed, but when it comes to the assembly, all of the faces, all of the circles, the edges, none of those are exactly the same as they were before. All right, they're in the same position, but because it's gone from a solid body to now a sheet metal body, it's not being picked up by these parts. So sometimes it's unavoidable, all right, that you do need to go and edit and replace these mates. In this case, these mates now, they don't need to be deleted, but you need to edit them and update them. So to do that, you would edit this mate, and you can see here, there's a reference missing. So it's missing a face. If you're lucky, it'll highlight for you where that missing face was, and you can just click on that face, and it'll add that mate back. and turn it back on. Okay, so there are different ways that you can deal with those errors. Alright. So getting into some of the main reasons why we use the assembly now, or some of the main tools, it's around validating your parts and your design. So it's okay to build all these individual parts, but when you start to assemble them, you can start to see where things are not the right size, holes are not the right size, matching parts, or some of the distances might be wrong, or the proportions might be wrong. The first thing we're going to do is what's called interference detection. So you typically do this once you've done all your mates, because you know everything's in the right position. It's now more about your design. You know, are things the correct dimensions? So click on Evaluate at the top, then click Interference Detection, and it's going to select the entire assembly. You can, if you want to, do interference detection between just 2 or 3 parts, just by selecting those and then hitting interference detection. But we're going to do it over the whole assembly at once because it's a pretty simple assembly. Press Calculate, and it's going to bring up or identify wherever you have interference in your assembly. And you can see that in the results. And you can see I've got quite a few there, maybe 20 or 30 interferences. And you can cycle through them. So when you click on them, they'll identify in red in the viewport where those interferences are. The other thing, if you click on the arrow, it'll show you with those 2 parts. So this is between part 6 and part 8. This one here is between part 6 and part 8. What you might find is there are a lot are very similar, and that could be because we have a thread on our nuts and bolts. And typically those threads, if we do a section view, you can see that that thread here is between the nut and bolt, they're intersecting. All right, that's perfectly fine. All right, we know that's normal. What's not normal is we can see here in our bush, that's interfering, that's an issue. That's something we need to rectify. Back to the interference detection, there's an option here to create a fasteners folder. You should check that. And then anything in this fasteners folder, you can press ignore. All right, so it won't pop up with those. So now I'm just down to 2 main interferences. So I've got one here between part 1 and part 2, and another one that's here between parts 1 and part 4. All right, so that's all up the top here. So I press the tick. That's just to help me identify where those issues are. So the first one, part 1 and part 4, let's have a look at that. I'm just going to make this transparent. You can see here this hole on the inside, it's too small. Right, so assuming that my size of the pivot pin is correct, I'm going to edit this one. Click on that hole, and you can see that hole's only 9, whereas the pivot pin is 10, so I need to make this bigger. So I'm going to increase that to 10.2. You can see now that's going to create some clearance, and that should be okay. So when I do the interference detection again, calculate, you can see that one's gone, and now I'm left with just this one here. For this one, which is in the washer, it's actually part of the sub-assembly. Now I can edit it here, or I can edit it in the sub-assembly, it doesn't make a difference. I'm going to edit this part 2, and I'm going to do a section view just to try and work out what's going on. And you can see that the washer isn't big enough. The hole in the washer isn't big enough. And my dimensions, I haven't updated my dimensions yet. So where I have that 14 diameter, that should be 18. And then the hole size, again, needs to have enough clearance for that pivot pin, 10.2. Now that's a lot better, but on the section view, I can still see there's interference there. If I turn this off, do the interference detection, you can see I've got some interference on these two corners. And this is where some people have picked it up already. This now has a fillet on those edges. All right, we're able to add that fillet on. So the way to add that fillet, we're actually going to edit the sketch of the revolve. Instead of adding a new fillet feature, we can just edit the sketch. When you're editing a sketch, you can now see in the assembly where the other parts are. We're going to add a sketch fillet. So I go sketch fillet, I'm going to put a size in, 1mm, select that curve, and OK. Now, that's still too small, but what I can do is just bump up that number to 2, and then I can see that that size is going to suit my assembly and my other parts. And looking at everything else, assuming everything's the correct dimensions, the clearance on the other parts looks pretty good as well. What you may have found, depending on what number you had here, 2.5 or 3.5, that there may have been some interference here, in which case you need to change that number and dimension as well. But overall that looks pretty good. So I'm going to accept the sketch, get out of edit component, do an interference detection again. All clear. Can save that. And now back in my general assembly, just do one more. Everything's clear. So I now know I'm good for interference across my parts. Question? Yep.
The fillet as a feature rather than you edit the sketch.
Why would I not use the fillet as a feature? You can do either. In this project, I'd like you to have a go at editing a sketch in the assembly, and that's the reason. Okay, but in reality, you can do either way and it will be fine. All right, any other questions on assemblies, issues? Yeah.
When I go back to the evaluate again, nothing's coming up, and it still says 16 experiences.
Yeah.
I feel like
So
it's
that
too many.
would that be like when I go calculate, I've got 32 ignored.
Yeah.
Those ignored ones are in the fasteners folder.
Yeah. How do I get back to that?
So to show them again, you need to press the button here that says show ignored interferences, and then it will show you any that you've ignored. So sometimes you can have interferences which are not fasteners, but you know that they're acceptable, so you can ignore them anyway. So you can click that ignore, and that way next time you do the interference detection, it won't pop up again and again and again. All right. Okay, good. We're tracking really well, guys, which is good. We've got one more thing to show today on assemblies. I'll give it a little break now. We'll do it in about 10 minutes, and then that'll be it for tonight. So if you've got any issues or questions on any of these parts, let me know now, or the dimensions you need to check, and then we'll come back in a couple of minutes. Okay, so the last thing that we need to do in your assembly for this project, and this is almost setting us up a little bit for project 2, all right, but it's a nice little feature to play around with, is exploded views. So you can see that button up there on the assembly toolbar, separates the components into an exploded view. So we're going to use this tool to create an exploded view in the assembly. In project 2, we're going to create a drawing that shows the exploded view. So the exploded view is used for communication, okay, to communicate to the factory or the assembly or the client how the object goes together. So very simple how it works. Press the exploded view, and it opens up this properties manager. You select a part, and when you select that part, it'll bring up these arrows, and to explode it, you click an arrow and you drag, and that's it, and it adds a step. Now, what you want to do is work out the order in which you want to do the parts, and you can do multiple parts at once. So if you want to click multiple parts, you just select them, okay, and then click the arrows and you can drag. All right. Now each time you add a step, that adds it here on the left. Explode step 1, 2, 3. You can reorder the steps by clicking and dragging them, and you can delete them. You can also undo. So I'm going to undo and just go back to the start. So if you think about the way that this would be assembled in reality, we would have first these bolts, side plate, reinforcing plate, side plate, probably even the bushes all come off at once. But we'll keep it pretty easy for now. So I'll do the bolts. Now I want to bring these off at the same time. I want to keep them all coming out to the side. So I'm going to select these two again in the side plate or reinforcing plate, then the side plate, then the bush. Okay, then I'll do the other side. You'll see the difference in a second. And this is not necessarily the perfect way to do it either. Alright, so that's exploded all the way out, both sides. The sub-assembly, I'm going to come back to that. So I'm just going to press the tick. Now that's an exploded view. When you save your file, it's saved within the file. You don't have to save a separate exploded view file. To collapse it, right click on the name of your assembly at the top here and press collapse. To explode again, right click, explode. Now I'm going to collapse it. I'm going to go to the sub-assembly just to do something in there. I'm going to do the same thing with an exploded view. This one's going to be very simple. Just going to go up and down here. That's it. Collapse. I'm going to save that. Close. Now, when you want to edit your exploded view, don't press exploded view button here. Every time you press this, it adds a new exploded view. Okay, so to edit the existing one, you need to click on the configuration manager above your feature tree. Press this drop down, and you can see exploded view 1 there. Right click that to edit feature, and now I'm in the edit mode again. Now the reason I did that little sub-assembly explode is for this. I can select this sub-assembly and I'll select it as a whole part. Alright. Now I can move that all together. If I want to move the individual parts, I have to tick this box down here, select the sub-assembly parts, and then I can select them individually. Alright. But the better way of doing it is to select that sub-assembly and press reuse sub-assembly explode. So you already create the exploded view in the sub-assembly. In your general assembly now, I don't need to recreate it. I can just hit that button and it's going to create that for me. Okay. So just some of the things I sort of skipped over here, and the reason I skip over them is because in all the years that I've done exploded views, I very rarely will edit anything of these settings. But what they are is, if I double click on this explode step 1, it shows me what parts are involved there. If I want to add a part to that exploded view, like to that step, I can select it here and press apply, and it will include it in that step. All right, or I can delete it and press apply, and it will remove it. The direction here, arrow, well, that you can change the direction, right? But once you've created the step, you can't actually go up or down or across. You can only go in one direction per step. The other thing you can do though, press done, is you can explode it at an angle. So if I wanted to explode this part at an angle on this line, I can select that line and then I can go in that direction. Okay, so if you want to go at a certain angle, that's the way you can do that. The other information here is, you know, the measurement. So if you wanted to explode each step 100 millimeters, you could do it by putting in an exact measurement here. There's a few other tools in there, and there's a radial explode here. I'm not going to worry about going over those tonight. You can have a look at those in your own time. But when you're done, that's the exploded view. So I'd like you to have that in your file, you know, before our submissions. To actually see how it works, you can press Animate Explode, and it'll show you the movement of parts. You can press Reciprocate and play. You can see it all goes together and pulls apart. Alright, so play around with that tool. You know, try multiple exploded views if you want. You can always right click on them and delete them, you know, if you're not happy with them. But these are just some of the cool tools to play with. When you get into more advanced stuff, you can actually create animations from this. So you create all your parts, you create your assembly, you create your exploded view, and then you can do a motion study here, okay, down the bottom of the screen, and then you can render out the motion study. So you can have a 3D exploded view showing, communicating how your object goes together. Alright, so there's a lot of different ways that these sort of tools can be used, but that's the basics for you. Yeah. Any questions on that stuff? Yeah?
Is there a way to like evenly space it rather than just
Yeah. I think the laughter here is because I explained that.
Oh really? Sorry.
That's alright.
I was laughing at
No?
It was not very
Okay. It's all good. Yeah, so there's the dimensions here. Alright, so when you do your step, like let's say this one, I want to move it to the side. So once I've moved it, I click on that step, and I can go here to the dimensions, and I can put in a number, and it will move it, once I press apply, exactly that amount. Okay? But typically, it's very rare that you need it to be perfect. If you're really pedantic about it, you can, but there's no real need. It's more a visual thing. In Project 2, what the task will be is to get these spaced out at a certain angle. It might be, none of these angles show it right now, but it might be an angle like this that I'll set, and you need to space them all out so nothing's overlapping. But that's Project 2, and we'll get to that then. Alright, anything else on these? No questions, it's good. Alright,